All right, we're ready for page 4 of the 7-1 notes. We're on example 13 here. We have a couple special situations where we're given a point and a slope, and we're asked to graph the line. Well, start with part A here. We're going to plot that point, 2, -5. It's right here. And then our slope is 0. So what does that tell you about the line? Hopefully you remember from about, I don't know, a video ago or so. It tells us that the line is going to be horizontal, right? And we could also say, well, if this is rise over run, 0 over, it doesn't matter what it is. It could be 0 over 1, 0 over 2, 0 over 5. We don't rise at all. We can run as far as we want, right? So I could run out to here, or I could run back this way, but I can't rise at all. And so we have a horizontal line. You could put another point wherever you like, as long as it's horizontal from your starting point. So we have a horizontal line. The next one we're told, and we have point 2, -5 again, but we're told the slope's undefined. What does that tell you? Well, it's impossible to climb the line, which means the line would be vertical, right? It means you have something over 0. Okay? So that means we're not going to rise at all, or so we're not going to run at all, but we could rise as far as we want. So we could rise way up here, we could rise to here, we could rise down below, but we're going to have a vertical line. We could put another point wherever we like, and as long as it's vertical from the other point, and connect them, got a nice vertical line. So there's a couple special cases where we're given a point and a slope, and we're still able to graph them as long as we know 0 slope means it's horizontal. Undefined slope means we have a vertical line. Okay. So now we're going to get into a couple of geometric terms, parallel and perpendicular. Parallel lines, as far as slopes go, they have equal slopes, right? And if you think about parallel lines, that means they never touch each other, right? So we have two parallel lines. If you think about that, would they have the same rise and run? Well, yeah, they would, right? We rise so far from one point to another point, and we run so far, and that would be the same. The rise and the run would be the same on a parallel line. Perpendicular lines have slopes whose product is -1. So perpendicular means they make a T, right? They make a 90-degree angle. So if we have one line, we have another line, we have a 90-degree angle when they hit each other, where they intersect. So perpendicular lines do intersect, and they intersect at a 90-degree angle. It just happens to be their slopes have a product of -1. Now what that means to a lot of you, probably, you've probably heard this, is that the slopes are opposite reciprocals. Okay, so perpendicular, better spell this right, perpendicular lines have slopes that are opposite reciprocals. That's probably how you learned about it back in high school or maybe even middle school. All right. So if we're given a couple lines and asked to determine if they are parallel or perpendicular, there are a couple ways you could go about it. I'm going to show you the easiest way. I'll talk about the harder way. You could graph them both and see what they look like. That can sometimes be misleading though, especially if they're perpendicular. It's hard to tell if it's exactly a 90-degree angle or not when you graph them. So an easier way would be to find the slope of both of them and compare their slopes. Now to do that, if you're given an equation of a line, these two are in what we call standard form, kind of like standard form anyway, with x's and y's are all on one side, which that is good for some reasons, but if you're finding the slope, it's not very handy. and so we'd like to put them in what we call slope-intercept form. And slope-intercept form, right over here, slope-intercept form is the form y equals mx plus b. If we can get the equations in that form, the m is the slope. And we can just pick the slope out and then compare the slopes to see if they're parallel or perpendicular, or possibly neither. Most pairs of lines are not either, but if you're asked to do this, it's probably going to be one of those, parallel, perpendicular, or it could be neither. So, to get something in slope-intercept form, we want to get the y by itself, basically. So to do that with this equation, I'll start with this one. I'm going to subtract the x. And so if I subtract x from both sides, we get 3y equals negative x plus 8. Okay? And then I'm going to multiply by 1/3. Okay? Some of you might say, well, why don't we just divide by 3? You could divide by 3, but it's a little easier to look at the line through a multiplication as far as all the pieces go. So I'm going to multiply both sides by 1/3 rather than dividing by 3. It's the same operation. The 3's cancel here. We get y is equal to 1/3 times negative x is negative 1/3 x. 8 times a third is 8/3. From here we can see that the slope is negative 1/3. And that's what we're going to need to answer this question, really. Now we got to look at the other line. Again, I'll get all the y's together. Here I'm going to add 3x to both sides to get my y by itself. So y is equal to 3x plus 5. Well, that one was kind of easy, right? So we're in slope-intercept form. Y equals mx plus b. Here we're in slope-intercept form. Y equals mx plus b. And we'll talk about what that little b tells us in a little bit. But here the slope is 3, right? So you can check, are the slopes the same? They're definitely not the same, are they? So they're not parallel lines. Are the slopes opposite reciprocals? They are, right? The reciprocal of 1/3 is 3, and the opposite sign is a positive 3. We could also multiply the two slopes to see that their product is negative 1. If we multiply negative 1/3 times 3, you get negative 1, and that tells us that these are perpendicular lines. So these two lines are perpendicular. And if we were to graph them, we could verify that they would look perpendicular anyway. So that's our first example. Let's look at the next one. Again, we have two equations of lines that are not in slope-intercept form. Let's put them in slope-intercept form. Here I'm going to add x to both sides. We get y is equal to x minus 7. Here I'm going to subtract x from both sides. I get negative y equals negative x minus 3. We don't have y by itself yet because we have a negative in front, but I could multiply both sides by negative 1. If I do that, I get y is equal to, if I distribute the negative 1 times negative x is x, negative 1 times negative 3 is 3. So let's see, what's the slope? This guy, there's an understood 1 in front of the x, so m is 1. Here also m is 1. We have the same slope. If we have the same slope, slopes are equal, then we have parallel lines. So these two lines are parallel. So, all right. Perpendicular, slopes are opposite reciprocals. Parallel, slopes are the same. Now we have another example here. These two lines are already in slope-intercept form. So we just have to compare the slopes. Here m is negative 5. Here m is positive 5. Are they the same? No, they're not. Are they opposite reciprocals? They are not, right? If they were, this would be a 1/5 instead of a 5. So these two lines are neither parallel nor perpendicular, and so we say they're neither in this case. Neither parallel nor perpendicular. We have one more example on this page here, and this example gives us kind of a real-life situation and asks us to find what's called the average rate of change. Well, the reason this shows up in this section is because average rate of change is just a fancy name for slope. So we have to identify 2 points and then find the slope. So we have 2 points in disguise basically here. We're asked to find the average rate of change in population per year. So I'm going to write population per year. What that tells me, if I'm going to find slope, is population needs to go on top, year needs to go on bottom. Well, what was on top? The y's, right? The change in y over the change in x. So we're going to find the change in the population divided by the change in the year. So if we're going to write this information as points, the y's need to be the population, the x's need to be the year. So let's go ahead and write this guy as a point. This state had a population of 755,000 in the year 2000. So as a point, for x's, or years, we'd have the year 2000 and the population of 755. Oops, I'm not going to use a comma because that might get confusing. So 755,000. And then the other year we had was 2012 and 809,000. Now we could just take these 2 points and find slope. So we subtract the y's. Let's see, 809,000 minus 755,000. And subtract the x's on the bottom, 2012 minus 2000. Again, make sure you're consistent. If I subtract this direction with the y's, I need to subtract this direction with the x's. Alright, so let's see what we get. I'm going to bring out my calculator. Let's see, 809,000 minus 755,000 is 54,000, right? So 54,000. And this is going to be 12, right? So if we take 54,000 and divide by 12, that's 4,500. And I'm going to remember what my units were because it helps me a little bit. These were populations, that's the number of people. So this is 4,500 people. And this was years, right? So it's 4,500 people per year. And this is reduced to 1 basically. So what this tells us, if we want to interpret the slope, is that this state, its population is increasing at a rate of 4,500 people per year on average. And that's what we call it, an average rate of change. So population increasing, 4,500 people per year. All right, so that's a little application of slope, and we'll stop this video here and go on to the next one.